Hi everyone, so this is the video where we start talking about the algorithms for multiplication. So just like with addition, we have the same two names of algorithms. So we have an expanded algorithm and a standard algorithm. So we will start talking about the expanded algorithm. So you guessed it, just like all of the other first steps of all the other algorithms, the first thing that we do is write the numbers vertically, and then we multiply, and then we sum. So before we get to doing this, since we're going to work in different bases, it may make things quicker and simpler to write a multiplication table for yourself, because we know the multiplication tables in base 10, right? We memorized those in elementary school growing up, but just because we're doing operations in different bases, it may help us to do this. So let's write a multiplication table for base 5. So we are multiplying, right? So we always put the operation in that corner, just like we did with the base block modeling that we did last video. So we look here. So we can write 0, but based off of our property, we know that 0 times anything is just 0, right? Based off the 0 multiplication property. So we don't have to include 0 in our multiplication table. So we can start with 1. We also know that 1 times anything is 1, but we're just going to go ahead and start with 1. Right, so remember that in base 5, we have digits 0 up to 4, and then at 4, we start carrying because we're in base 5. So we can go ahead and write that 10, and then we have the same thing going down. And that's as far as I'm going to go. You can go further. You can go as far as you want, just whatever is most helpful to you. And we are multiplying. Okay, and you should also indicate what base this multiplication table is in whenever you're writing out your work. Someone could look at this and see that you carried at 5 and you only went to 4 and then denoted the value 5 by 10 and know that you had that this is a multiplication table for base 5, but just to be safe, we should do it this way. You should always indicate what you're doing. Okay, so we can fill in the first row and column pretty easily because we know that 1 times anything is the same thing. Okay, so now I think what comes most natural to probably all of us is to just know the multiplication facts in base 10 and to then convert that value into base 5 to write it in your multiplication table. Just because we deal with base 10 so much more often, it is definitely going to come more natural to do operations in base 10. So just keep that in mind, that it's okay if you do these in base 10 and then convert them to base 5. That's okay. If you need to do that, if you can just write down whatever the base 5 multiplication is, then you really know in this base 5, but you don't need to do that. Okay, so now let's do 2 across. So 2 times 2 is 4, which is denoted 4. 2 times 3 is 6, which has 1 5 and 1 left over. 2 times 4 is 8, which has 1 5 and 3 left over. And 2 times 10, sorry, see, it's just so natural to say it like this. 2 times 10, 2 times 10 is 2, is the value 2 times the value 5, which is 10, which is 2 5s, and no, nothing left over. Okay, now let's do, right, because of this commutative property of multiplication, once we know a row, we can fill in the corresponding column. So we have 2, 4, 1, 1, 1, 3, and 2, 0. Okay, so now we can do 3 across. So we know 3 times 1, we know 3 times 2. Now 3 times 3 is 9, which has 1 5 and 4 left over. 3 times 4 is 12, which has 2 5s and 2 left over. And 3 times 10, which is the value 5, is 15, which has 3 5s and none left over. Okay, so now because we filled in a row, that commutative property tells us we can fill in a column. So we have 2, 2, and 3, 0. And now 4 times 4 is 16, which is 3 5s and 1 left over. 4 times 1, 0 denotes 4 times 5, which is 4 and none left over. And then we can fill in that 4, 0 here. Lastly, we have 1, 0 times 1, 0, which is 5 times 5. 25 has 5. 25 has 5 5s and none left over. Okay, so this is a multiplication table for this. Like I said, this goes on, right? You can keep filling in values here, but you don't have to. This is all I think that I would do before looking at the problems, just so we know how to do everything. Okay, so that is our multiplication table. So now let's go on to actually computing this example. So, like every algorithm, our first step is to write things vertically lining up the place value. So we are looking at 1, 2, base 5, times 2, 3, base 5. So we just line everything up. Okay, so the expanded algorithm says we multiply by place value and then add the product. So essentially, you can view this in 2 steps. So we're going to multiply the 2 here by each of these values, and then we're going to multiply the 1 by each of these values. So we're going to get essentially those 4 sums, those 4 products, and then we're just going to add them up. These are going to be our partial sums. So first, multiply. I'm going to start by multiplying by this 2. So the first thing I'm going to do is a 2 units by 3 units. So 2 units times 3 units is going to give us 6 units, which we regroup into 1 flat and 1 unit. Okay, the next thing I'm going to do is take these 2 units times, 2 units times 2 flats. So this is going to be 2 units times 2 flats. So we make sure we denote the place value there. So when we have 2 units and 2 flats, then we are going to get a total of 4 flats. So this is 4, 0. Okay. Next, I'm going to go over here to this 1 and multiply it by the 3 units. So we're going to have 1. Oh, I'm sorry. I said flat when I didn't mean to. Those should have been saying long because we only have 2 place values in this. Every time I said flat, I should have said long. My apologies. Because we only have 2 place values, we're only dealing with units and longs. Okay, so I'm going to take this 1 long, right, which is represented by this number 1, 0. I'm going to take that 1 long and multiply it by 3 units. So we know the units just copy that many longs. Okay, and lastly, I am going to take my 1 long and multiply it by 2 longs. Remember, whenever we multiply a long by a long, we get a flat, and we're going to get 2 of those. 2 of these flats, and we're just going to add up all of these partial sums. So we're going to add up all these partial sums, regrouping as we go. So 1 plus 0 plus 0 plus 0 is 1. 1 plus 4 plus 3 is 8, which has 1, 1 5 with 3 left over. And then we're going to add 1 plus 2 to get 3. So this tells us that 1, 2, base 5 times 2, 3, base 5 is 3, 3, 1, base 5. Okay, so that's how we do this expanded form. So it's kind of a lengthy process, right? Because we have to do, for every digit, we have to multiply every digit of the first number by every digit of the second number. So in this case, since we had 2 digits in the first number and 2 digits in the second number, we added up 4 partial sums. So with our next example, we have 3 digits in the first number and 2 digits in the second number, so we're going to have 6 partial sums. So let's start. So we have 3, 2, 4, base 5, and 1, 2, base 5. We're multiplying these together. Okay, so I'm going to start with this 4. You don't have to by any means, because we're just adding partial sums. We could start with that 3, or we could start with the 2, or we could start with the 4. But I'm just going to start with the 4. But your students and you can start with whatever you want. You can just multiply and make sure you hit all of them. So I'm going to start doing this 4 units by 2 units, which is represented 4 times 2. 4 times 2 is 8. So we have 1 5 with 3 left over. Okay. Next, I am going to do 4 units times 1 flat. So 4 units times 1 flat. Okay, so when we multiply things by units, we just copy it down. So this is going to leave us with 4. I'm so sorry. Again, I said flats. So we have 4 units times 1 long. So units times a long is a long, based on the area model. Okay, so that takes care of the units. So now I'm going to multiply 2 longs by 2 units. So just like before, when we have units, we just copy the same thing again. So this is going to result in 4 longs. Okay. So now we're going to do a long times another long. So we have 2 longs times 1 long. And remember that a long times a long is a flat. So this is going to be 2 flats and nothing else. Okay. Lastly, we're going to come over to this 3 and multiply it by a unit. So we're taking 3 flats and multiplying it by 2 units. So if we have 3 flats multiplied by 2 units, that's going to give us 6 flats, which we're denoting, right? We have to carry, so we have this denoted by 1, 1, 0, 0. And lastly, we are multiplying 3 flats times 1 long. So we have 3 flats times 1 long. Well, 3 times 1, so we're just going to have 3 of these. So now we're going to add all of our partial sums. Going to add all of our partial sums. So 3 plus 0 plus 0 plus 0 plus 0 plus 0 just gives us 3. No regrouping necessary. 1 plus 4 plus 4 is 9, which has 1 5. We have 1 5 and 4 left over. 1 plus 2 plus 1 is 4, and 1 plus 3 is 1. So that gives us our answer. So we have that 3, 2, 4 base 5 times 1, 2 base 5 is 4, 4, 4, 3 base 5. Okay, so that is the expanded algorithm. We just have this expanded form. So yeah, like I said, this is kind of a lengthy process. However, talking through this and saying what is the unit and what is the flat and what is the, see, I keep skipping long. What is the unit and what is the long and what is the flat, again, helps really reinforce that place value. And you can do this in any order. Another thing that's really nice for students who are learning it is that whenever we're writing this list, this is the only place where the multiplication, oh, ran out of room. I'll rewrite that. This is the only place where the multiplication happens, is in this list, right? So this list is where the multiplication happens, and then we add everything together. So we don't add anything until the very end. So we do all the multiplication, and then we do the addition to get our final answer. So that's another nice thing, is that it just takes a long time, but it's nice and you see everything that's happening. Okay, so that's all for this algorithm, and next time we'll talk about the standard algorithm and how it's different.